In the world of sports cars, you got Ferrari, Lamborghini, Bugatti, McLaren. In the world of private jets, you got Gulfstream, Falcon, Bombardier. But when it comes to backcountry flying, there's only one aircraft that has the same level of pedigree. Welcome to CubCrafters.
Fly high, touch the sky. Flying forever, reaching for the
Welcome to Yakima, Washington, home of CubCrafters aircraft. Whether you're picking up a factory certified aircraft or you're doing the build or assist, this is where it all begins. People that buy these aircraft know they're just not buying an airplane. They're joining an exclusive club with people that live for performance and craftsmanship. It's the difference between driving a minivan or a supercar, flying in style and highly capable. It's like going to Cars and Coffees in your Lamborghini, except way cooler. Why? You have wings. But as you hear throughout this tour, it's all about quality, craftsmanship, and innovation. But more importantly, people. People coming together, people making a difference. CubCrafters owners know this incredible aircraft is an extension of their personality, allowing them to create incredible experiences and long-lasting memories. CubCrafters might be in the aviation industry, but they're in the people business. So join me on this tour as we walk you through in depth on how incredible this factory is. Let's get going. Now, not every CubCrafters aircraft is a Carbon Cub, but every Carbon Cub is a CubCrafters aircraft. Well, we're going to begin our journey here in the Composite factory with Robert Detloff, who's the Director of Manufacturing, and we're going to get a real good sense of why the name Carbon Cub has stuck to this brand for so long. Hey, Robert. Thanks for your time today. Really appreciate getting the chance to show this incredible factory. I can see we have a lot of carbon fiber here. But before we get into the manufacturing and stuff in this facility, I'd like to talk to you a little bit about where the word Carbon Cub came from, because I know, like we said, not every single CubCrafters aircraft is a Carbon Cub. So what was the evolution of how that came about?
Yeah, glad you could be here with us. So CubCrafters started building spare and surplus PA-18s. That transition to eventually designing their own aircraft, that necessitated some fiberglass composite components. And then eventually, carbon fiber started to be one of the leading products for strength and reduced weight in aviation. And once we transitioned out of our first production model, we went into our Carbon Cub and we started optimizing as much as we could in the aircraft with carbon fiber products.
PA-18, and then we went into, was it the SS at that point?
The Sport Cub was the first production model that CubCrafters made.
At what point did you call them a Carbon Cub?
2011, 2012 is when the Carbon Cub first came out. And that was when we didn't retire the Sport Cub, but that was the 180 horsepower, much bigger, much more of a high-performance backcountry aircraft instead of a snortier version of a Cub.
Okay. Yeah. And then as the brand evolved and the product line evolved, and then now we get into the XCub, the FX3s, and technically the XCub is not considered a Carbon Cub, but Carbon Cub has created such an incredible name in the industry that it kind of stuck, like the word Kleenex or shipped at UPS. Everybody considers that type of plane a Carbon Cub. But can we go start at the very beginning?
Absolutely, let's
go. Can you kind of walk me through all the pieces and components that are made in just this building?
Sure. So our composite facility is everything that's made of carbon fiber, fiberglass. In addition, we make molds, we machine molds, we hand sculpt molds. So we're gonna kit from a raw material fabric. We're gonna hand that off to our layup technicians. They're gonna go in and drop that into the mold according to the print. And then that'll get infused with resin. It'll get popped out of the mold. It'll get trimmed. It'll get, if there's additional work here, or it'll get shifted off to another part of the facility depending on what component it is on the aircraft.
And I see you guys have a lot of molds here. Do you make your own molds and maintain them here?
Yep, absolutely. Every single mold that we have here, we've manufactured, either hand sculpted, or increasingly we're using a CNC-milled to make our molds.
So Josh, you're doing one of my favorite operations in this whole facility. CAD design, 3D work, CNC.
Did a little demo for you guys. Going to show you some multi-action. Right here is true machine simulation to where it's literally doing what the machine is doing right now.
So things like making sure that the bit's not going to hit the bed or stuff like that. This is high density foam.
Yes.
So it seems like you guys are making your own molds and things like that out of high density foam,
Yes,
right?
you're correct.
Okay. And that's pretty hard.
We actually even have harder. This is actually only 20-pound density. This is mainly what we use to be able to not create our molds, but our plugs, where we have all the way up to 50-pound density foam that will actually take the heat or strain.
So you're saying you can actually use this to actually lay the fiber right on it, and
Absolutely.
as well as make molds out of it.
Yes, absolutely.
Okay, that's pretty cool. Why would you do that? Maybe some one-offs or something?
So in that case, they would literally make the mold and then create a plug and then create the mold off of that. So it's more in depth. I'm machining it, as you can see, I'm machining it from the top, not from the bottom, trying to get into.
So basically what we're saying is we're going from a positive to a negative that
And back
creates
to
a
a
positive.
Yes.
Kind of like you see in Hollywood when they're making masks for some of the actresses and things. And then from here, it goes on a stick over to the CNC.
Yes.
Love this area. Thanks for taking the time to explain it to me.
Not a
Appreciate it.
problem.
Thanks,
Anytime.
Josh. Take care.
Anytime.
Okay, so can we go start where the fabric gets laid?
Absolutely, let's set up.
All right, great. Tell me a little bit about a couple of the fabrics you're using and why you're using these.
From a process standpoint, when you hop in the airplane, you're going to look over and you're going to see your interior panels that are going to be a clear carbon fiber weave, and that's what you're going to see here. Very difficult, very technical to get that in without the weave being distorted. Your other types of products that are going to be a structural sewn carbon fiber, you got fiberglass. So this is your infusion media, your flow media. So that's going to allow that resin to flow through the mold under vacuum. And then this is what's going to seal that mold off from air to prevent any air bubbles from getting in and corrupting your part.
Now, are you using pre-preg or just straight carbon fiber?
We use both. So, we use a vinyl ester resin, open face infusion process, so a little bit different than what you do, where we're going to bag everything, we're going to pull a vacuum on it, we're going to get as much air out of it and get it as tight as possible before we pull that resin into it, so we can mitigate that question of excess resin for weight reasons and aesthetics and whatnot.
Okay, great, and we're going to see that process downstairs.
Yep.
And just so everybody knows what pre-preg means is pre-pregnated. So basically the materials come with the resin perfectly measured and already impregnated into the actual carbon fiber fabric.
That's right.
And then so you don't have to actually pull resin into it or do any kind of wet lays because it's already built into the fabric.
That's right. So you can control your weight much more carefully. There's advantages and disadvantages. You got to keep the product frozen. And there's some new technology where there's room temperature pre-preg materials, but yeah, you can control your resin and you can get a much tighter part that way.
Okay. And then the peel ply, just so everybody knows, which we'll see downstairs, is after you lay all the carbon fiber in, if you're pulling the resin in and all that kind of stuff, the peel ply goes on top of that so that you could pull the bag and the peel ply away from the carbon fiber once it's all cured and it doesn't stick to the materials that you're manufacturing.
Yeah, that's correct.
Okay.
Yeah, the peel ply is like I believe it's a silicon-based product that doesn't allow anything to stick to it, and so that you can separate all your bagging film, your flow media, and everything off of that part and just leave you with a part.
Okay, so let's go to the table.
Yeah.
Because this is where it comes off these rolls, they lay it on a table, and then what happens from this point?
We have patterns that we will generate a piece depending on the geometry required for the part. We're just going to lay that pattern down. We're going to use our electric scissors and we'll cut that pattern out. We'll take every raw material required for that part, including your flow media, your bagging film. We'll stage that in what we call a kit, and we'll put that down on the shelf to be picked up by one of our layup technicians as needed in line of production. That way the folks that are doing the layup can completely focus on the layup process and don't have to worry about raw material.
While we're here, I want to talk a little bit about the manufacturing process and how you guys track everything. Now I know you have things that are like assemblies, sub-assemblies.
Yep.
You know, you've got multiple sub-assemblies that create a master assembly, and some manufacturing processes, we call them parent-child,
Right.
pallet pieces to parent, and that's kind of what we have here. So can you kind of walk me through all of your process and your paperwork and how that actually works as it goes through the facility?
Essentially, this is a map for multiple reasons. One, it's for the individual technicians involved in the manufacturing process, so they know exactly what the next step of the part is. In addition, it's a tracking system through our ERP system, so we know where a part's been, we know who did it, we know what products were used in it. Going into a deeper level, that's the requirements for building certified aircraft. is to be able to know what products went into what parts at what time and that they went in the right condition.
Of course, we got barcoding and all kinds of great
Yep.
stuff. So I know we'll see more of this as we go through the facility.
Yeah, this is everywhere.
So Robert, this looks to me like a seat mold. So you guys have a ton of molds here.
Yeah.
Do you make all your own molds?
We do, yep. Most of our molds are hand sculpted. We're transitioning into a CNC manufacturing of our molds with some new technology of scanning to be able to capture the legacy of our molds. Where we were before was our kitting process. So once this mold is done being prepped, it's going to meet the kitted parts at the layup area, and they'll begin the process of laying up the part.
So what else goes on this before you actually lay the fabric?
So once it's done getting the wax coating on it, we'll go through and we'll gel coat it. And that is your first layer is your gel coat, and then your fabric or your carbon fiber fiberglass layers will go in over the top. So that'll be what's presented when you pop that mold. That'll be your
Get that
finished
really
base.
nice shiny.
Yeah. Well, in this case, it'll be black gel coat, but we do a few different colors depending on what the need of the part is. Once this is ready and it's sprayed in the booth here, it's going to come over to our layup technicians. They're going to grab the kit, they're going to grab the mold, and they're going to start laying up that part.
Let's go check it out.
All right.
Looks like now the mold came out of the gel coating. Now, is the gel coat fully cured and dried, or you wait till it's tacky and then lay in the carbon fiber?
Generally, the gel coat's cured. It doesn't want to be over cured. You don't want it under cured. So once it's sat for a little bit to set, we can bring it over and begin the layup process.
Okay, so the layup is then, they lay the fabric on it, halfway over, they put a little spray glue on here,
Yep.
and then he lays it down and just molds it in.
Yeah, so that glue's just going to act as a temporary hold down to keep that fabric down into the mold. In this case, it's clear carbon fiber, so Antonio here has to be really careful that he doesn't distort the weave at all, because that's going to show on the interior panel when you're inside the aircraft.
Right, so you'll see the lines will kind of be zigzag as
That's
opposed to perfectly straight.
That's right.
Yeah, it's an art. It looks
It's
really
truly
good.
an art.
Now we're going to go to where they start to bag it and get it ready to infuse the fabric, correct?
That's right.
How many layers go on here?
It just depends on the part. So every part has a different intention and purpose, and depending on what that purpose is going to determine the layup schedule. So in this case, it's an interior panel, so it holds no structural purpose to the aircraft. So it's going to be a pretty lightweight piece of the aircraft.
Okay, great. Let's hit the bag.
All right.
The fabric is laid up on the mold here. You've got some gum tape going through here. Now, I see we got some funny looking things here that look like rabbit ears, but they're actually pleats, right? And the pleats are there to give a little extra fabric so that all of the bag sucks down onto the mesh here. And I can see what's happening is he's pulling the vacuum and he's pulling the resin through. This mesh allows, it's kind of shaped in a way that it's kind of like up and down and around, and allows the resin to kind of flow through into it. How many pounds do you pull on something like this?
This is about 29 inches of mercury is about what our vacuum pressure is.
So we've got resin coming in.
Yep.
And then the outside here, I see that this kind of hose is all spiraled. And is that where the actual air is being pulled from that goes up into this tank?
Yeah, that gives a solid channel where you can't get a seal that allows vacuum to be pulled from the entire perimeter of the part.
Okay, that's pretty cool. I like to see this process.
Beautiful process.
I'm sure that a lot of people haven't seen how this actually works.
Yeah.
I know you hear the term pot life. What does that mean when it comes to resin?
The resin has to get activated. It's a 2 to 3 part resin, so it gets activated, and the pot life is how long will it remain able to be infused into the part. So if you let it go too long, it'll cure too quickly. You can make it faster or slower. So depending on the geometry of the part, if it's a bigger part, you're gonna mix the resin. The pot life's longer, so it has longer to move through the part.
So it doesn't cure before it gets to, because it could cure and it didn't finish getting all the way into the nooks and crannies?
That's right.
Okay.
That's right.
After he infuses this, about how long does it take for it to cure and we can start to unbag it?
So we have a minimum cure time of 6 hours, but generally speaking, everything that we infuse is gonna cure for 24 hours. We always do a 24-hour cure, make absolute certain, and we pop the next morning. So this allows your resin to flow through, and it can be really unique. Sometimes you'll have to have multiple ports on a part and pull resin from a couple different places. The technicians always have to ensure that there's no air leaks. So we have a couple different instruments that we can listen for air leaks on the thing to make sure if you got a little air leak somewhere, it's gonna,
squeeze them up, find them.
It'll allow that air in, and that'll corrupt the part and either have dry spots or bubbles or whatnot in the part and ruin your part.
So this is a perfect example of preparation is the most important piece in the
Absolutely.
process.
There's about 8 different types of errors that can happen in an arc of life of a composite product. One of them is islands, where you'll get a dry spot where resin didn't get to, and that will ruin your part. If we have that happen, we may change the location and placement of where we infuse our resin, where we pull our vacuum, in order to mitigate errors like that.
How do you know how much resin to mix to the size of the part that you have?
Essentially what we've done over time is we've made enough of these that after a few trials and errors, we can see, okay, we're gonna need 1.5 cups, 2 cups of resin in order to fill this without having a bunch of excess that we'll have to throw away in the end. It's a process of, you know, you look at your surface area, you look at your layup schedule, how many layers you have. We can get a general estimate of how much resin that's gonna take. We try it, we have to go heavy at first, just because if you don't have enough, you're in trouble.
There's usually like grams per weight of fabric, but it seems like you guys have really fine-tuned that to minimize waste and really kind of narrow that down.
Absolutely.
All right, great. What's the next step after this?
Well, this part's gonna cure for 24 hours, and then it'll get popped out of the mold, and then it'll go over to our trim area.
This looks like our seat that went in for gel coat and now came out. And I guess you have to lay this opposite to what you think. So obviously I see the first part that's going on. We've got the peel ply that goes on top of the gel coat. Then I see that he has spiral hose that he taped all around that we just saw in the infusion process.
Yep.
And then over the top of that goes our bagging material.
That's
correct?
right, your bagging
Now,
film.
The carbon fiber fabric is already on that, right?
That's correct.
It's right on top of the green mold that we saw that has the gel coat and that gets
Correct.
laid with we saw.
That's right.
Okay. Where do we go next? To trimming?
We'll go to trimming. We'll see a pop part in the morning.
Day 2, this cured for 6 hours at first, then it went to 24 hours. You guys left it overnight?
Minimum 6, and we typically leave everything to cure for 24.
Okay, and then Alberto's gonna pull this apart for us in a second, but I had some questions from what I see here. You know, I noticed that on this particular mold, obviously this is our sheet that we've been following through the production process.
Right.
You got tape, your gum tape going like all around the back and stuff.
That's
Why do we need that?
To optimize the outcome of the part, we built this as a 2-part mold, so we can split it and pop everything out, and it makes it easier, makes it reliable, just a much more consistent output, having it as able to separate those 2 molds out rather than having it a single piece mold.
Have a single mold. Okay, great. Now, question for you is, once the 6-hour first period cure is done, do you have to keep pulling a vacuum on it, or do you just seal it up and leave it?
We typically seal it and leave it.
Okay, so the vacuum's not continuously running for.
We'll lock, you know, we'll clamp the hose, so essentially it has a vacuum pulled on it. But once that 6 hours is over, it's cured. We can technically pop it then. So typically we'll just leave it clamped, and then in the morning we'll pull all that stuff
So
off of it.
that must be the reason when we went back to the beginning process, you pulled the vacuum and you waited and tested it to make sure it was not leaking anywhere.
That's right, to validate that it maintains vacuum on it, so we don't pull any air into it and get air bubbles, and which can cause dry spots or voids in the resin.
Okay, great. So I can get a little bit of violet, and it is carbon fiber and stuff. So we got our glasses on, and
Yeah.
Alberto's going to dig into this and
Yep.
walk us through it as he's pulling it apart, what he's doing. And
Okay,
things.
so he's just gonna start cutting off the vacuum hose, and it's you know, the difficult part of this type of composite work is that you have 3 primary raw materials that are in the end garbage. You have your bagging film, which you see there. You have your green flow, your flow media underneath, and then you have your peel ply below that. Your spiral wrap, we talked about all that. And that's the difficult part, is you pay for all that, you have to buy it all, but in the end, that goes in the garbage can, and that's just part of the sacrificial process of manufacturing the part. So he doesn't have to treat any of that stuff carefully. He can just get it out of his way as quickly as possible. We've been experimenting and looking at some different techniques of how to optimize this, reduce the amount of waste that comes out of this process. And it's emerging technology, you know, with silicon bags, they call them, and it's still emerging. It's not totally dialed in yet. It's expensive.
Now, is he the main one that pulls all the parts, or does everybody pull parts?
Typically, everybody in the morning will have everybody come together and pull all the parts so we get it done really quick, and we can cycle them all into trim to make sure the trim room has plenty of work.
Okay, so unlike a lot of other areas in the production process, this building is really like everybody works together on all those parts one day. It's kind of like everybody in sequence together, and then the next morning they pull, then they get back on laying the next parts for the day. So it's all like all parts all at once, and it's not like a production line, so to speak.
Especially when we have a builder, because the builder comes through, they do all their parts, and we want to get those all out and into process as quickly as possible. So they're all laid up, that builder's parts are all laid up at the same time, they're all infused at close to the same time, and then they're all popped at the same time in the morning.
Okay. Now, is a one-day production schedule here do all the parts needed for one plane, or is it multiple days to get one plane done?
It's multiple days to get a plane done. It depends on your model. So FX3, Carbon Cub, UL are roughly 80 composite parts, where an XCub X23 is going to be about 180 composite parts. So, you know, and our rate through the shop fluctuates.
So it could take a couple of days to do the parts for one
That's
plane.
right.
Then. Okay. This is our seat. We watched it get all waxed and get gel coat prepped. Went inside the paint hanger to get prepped to lay the fiber on it.
Yep.
Now we have our finished piece here.
That's right. So yeah, we popped it, and you can see you got the finished side with texture here. This will all get cleaned up and dressed. You got the rough side, which will be covered by the upholstery, so it'll get some more cleanup as it goes through the trim process.
Next step for this is where?
This is going to go to the trim room and get all the excess material trimmed off of it, and then it'll be kicked over to our prep area.
This looks like where all the Martians work, right?
That's right.
Now, from my history, I know what a clean room is.
Yeah.
Clean room is something that's positive pressure that keeps particulates out, maybe 5 parts per million or something. And companies use clean rooms to like make chips or CD-ROMs or computer parts where it has to be really, really clean. This seems like it's the opposite. It looks like it's a negative room. What's this all about?
It's a negative room, so we're pulling a vacuum in the room, and then the gentlemen inside are in pressurized suits. So it's a very dirty process. You're cutting composite parts to their final geometry, and you're making a lot of dust and a lot of noise and a lot of mess, and so we pull that mess out with a vacuum. We protect our technicians with a pressurized suit to keep that dust out. So it's a little bit of both.
Carbon fiber, if anybody hasn't worked with it, it's like pieces of glass that can literally cut you and things. Trimming off all those pieces. So here's a perfect example of, this is what came out of the mold. And then they're basically just trimming to what the finished part should be right?
That's right.
Because these are
Very sharp.
Pretty hazardous.
Yeah, very, very sharp.
After it comes out of this room, it goes to staging, getting ready for assemblies, or go to the next facility, right?
Well, first we're going to inspect it.
Okay.
So we're going to validate that we made that part the way we're supposed to make that part, that it's got the reinforcements in the right place, it's the correct geometry, there's no skews or dry spots in the part, and then it's either going to go to our subassembly area or distribute it to whatever necessary part in the factory.
Okay. So let's talk a little bit about what a subassembly is. Like, he's making some parts here where it looks like he's kind of putting a couple of the carbon fiber pieces together. We got some other parts here, which looks to me like a heater duct for an FX3.
That's right.
So a subassembly is not just a carbon fiber piece that's finished, that's heading out of the building to inventory, but it's pieces put together and get as much done as you can, yeah?
Yeah, the intent is that we minimize the amount of handling and work that has to be done on a part at the main line. So they get a part, it can just go right on the aircraft. So in this case, we had 2 different half shells that get laminated together. We've got some RTV sealant with a gasket installed here and some nut certs on the other side.
All right, great. And then from here, we're going to head over to the next building, which is what?
We're going to go to the machine shop and see where where all the metal parts are made, basically.
All the fun stuff. Let's go over and hit it. Another fun building. Lots of heavy equipment here. A lot of presses, brakes, molding equipment, saws, welders.
Welders are on the other side.
The other side?
That's
Okay,
our last building on this side.
All right, so I guess let's start where the raw material is. What are the major types of aluminums you're using? 70, 75, 50?
60, 61, 50, 52 are 2 of the primary ones. There's there's a variety, and again, it all depends on the design intention. You know, different materials have different properties that serve better in one place versus another, and that's how our engineers are going to determine what type of aluminum goes in a specific place.
We do have some solid bar here, other tubing. So the fuselage is the steel tubing, right?
That's right.
Whereas mostly aluminum tubing and stuff get used.
So you'll have some, whether they're fuel lines, whether they're pedostatic lines, there's all sorts of little bits and pieces that may not be used in large scale, but that might be used for just 1 inch on an airplane. Some of it's for R&D use. It might be that we were trying something, experimenting with something, and that was the raw material we needed to conduct that experiment.
Okay. Then we have big pieces of aluminum
Yep.
for CNC milling and things
That's right.
like that.
Torque
Water
tube
jet.
masts, things like that.
And then sheet. Now I noticed that all of the raw material have a certain number on them.
Yeah.
These lot numbers?
That's right. So everything that we put on an aircraft, we have to be able to say we bought it from this company, that company bought it from this mill, that mill bought the raw stock from this place, the ore that made that metal came out of this mine. So we have to have traceability from the entire process all the way down to the part that goes on the airplane. And so it starts with receiving and labeling everything in the system with a lot number.
Okay, now we should remind everybody the reason for that is at CubCrafters, you guys build every aircraft as if it's a certified aircraft.
That's right. They follow
Even
the
though
same process.
some might be experimental,
That's
but
right.
everything is the same exact process and it's a certified aircraft.
Yeah, it's an easy way for us to make sure, one, to maintain a high quality standard on every product that we build.
So we've got routers here,
Yep.
but I see you have a router and a water jet. Like, what's
right.
the biggest difference? Why do you have both?
Depth of cut really is we're gonna cut all of our sheet metal, our ribs, our nose ribs, etc. are gonna be cut on the router. It's not good at cutting deep, heavy, hard material. So anything over about 3/16 of an inch, we're gonna shift over to our water jet. Anything that's steel is gonna be cut on our water jet. It's clean, it's effective, it's efficient, and it makes sure that we're treating the material in the most effective way of cutting it.
Okay. So you would cut on the router like flat stock that then we might go into a stamping or a brake
That's
or
right.
something like that where you're forming the ribs or
That's right.
the wing roots and stuff like that?
Yep, that's right.
Okay. Struts.
Yep.
Now, what's in this water? Why is it muddy?
Water jet mixes garnet with the jet of water, and as it hits, it's going to blast that metal. So this is probably a mixture of metal and rust and dirt, and getting filtered out and cleaned up so we can use it and optimize it as best as possible.
Okay, so the water goes through the table, comes up the top, and then all the heavy stuff floats to the
Settles
bottom, and the cleaner water goes to the top, goes through another filter, and gets reused in the jet.
Push right back into the bed.
Okay. Now, is there material in the actual water that helps with the cutting?
There's garnet, but that's only injected at the nozzle. It doesn't remain in situ with the water itself.
I see some parts we have here that, again, I see all of your, I call them a bomb,
Yeah.
bill of material.
Yeah.
Is that what you guys call them here?
So it depends. So this is a traveler. So this is more what I would call a map. So this is going to detail the map or the places that this part's going to go. Now, when it gets to an assembly point, it's going to have a bomb, which will look almost identical. That's going to show every single part that goes into that assembly.
Okay, great. So this obviously came off the
The router.
router.
Yep.
And then it's going to get stamped.
Yeah, it's going to hit our press brake.
Okay, great. Let's
Yep.
go look at that.
Yeah.
Obviously, these are brakes, right? So what are these machines used for in something like this?
Bending metal.
That's
They're
it?
exclusively for precisely bending metal.
So this came off the router,
Yep.
and so far there's only been one bend.
Mm-hmm.
So the router made all the holes, and then right now they're bending it. So we got one bend into it.
Yep.
Next one is going to be another bend
Yep.
to form this part. Would that then be a finished subassembly?
Correct. Well, not quite finished. And there is one interim process we didn't discuss. Is once it comes off the router, it goes over to our deburr folks, and they're going to go through the entire perimeter of that part, and they're going to clean any burrs or sharp edges off that to include deburring the holes on both sides. Little detail in the system. And so now it'll get a couple more bends on it, and then it's going to kick over to our other shop that we're going to go see next, and then it'll start getting some rivets and other pieces added to it.
Okay, great. Where's the next machines we're going to?
We're going to see the rubber pad press, or AKA Hydroform.
Okay, so this is one of my favorite things to watch, and it's the press.
Mm-hmm.
So how many tons is this press?
This is a 310-ton press.
Okay, and what's the type of press they call this?
So technically it's a rubber pad press. So you got a great big chunk of rubber up underneath here that looks like that, in addition to these smaller pieces that go on it.
So this is our die. So this comes from the router, and
right.
it's usually flat.
Yep.
There's a couple of holes here with pins. What are these
Yep.
for?
So those pins, when it's in flat form, get put in to hold the raw piece or the base piece onto the die. So as the rubber forms around it, it doesn't slough or push the rib off to one side.
Flat piece goes on, alignment holes and alignment pins. Rubber piece comes down,
Yep.
forms it,
Yep,
and that's it.
that's pretty much it. Yep,
All right, great.
pop it off the mold and do the next one.
Now this looks to me like the nose rib of maybe an aileron or a flap.
That's exactly right.
All right, great.
Yeah,
All right, let's go to the next one.
all right.
So I see millions and millions of dollars of all this high-tech CNC computer controlled equipment and things. And then I look over here and I see equipment from World War II.
Right?
So manual lathes, manual mills.
Yep.
Tell me, why in such a high-tech facility would you guys have equipment like this?
So there's always going to be circumstances and conditions where writing a program is not the appropriate way to make a part. It may be that you got to get it an oddball angle and you can rotate and tilt this head different ways, and it just may not be cost effective to set up a part to run on a CNC machine. And so these, I think, will be indispensable for many, many years into the future, where a lot of people, as you say, look at it and say, well, that's what, built the equipment of World War II, but they're not obsolete. In addition, we use these to make a lot of the fixtures and jigs that we're going to use in lots of different places throughout the facility.
All right, great. So I want to go from World War II to spacecraft equipment.
Yeah,
Let's head over there.
Yeah, so I'm going to hand you off to our resident expert, Craig. He's going to walk you through some of our CNC machines.
Hey, Craig. So, Craig, I see there's all kinds of different sizes, different types of machines, and different types of CNCs here. Can you kind of walk me through a little bit, a minute or two on each machine on why they're all different?
Absolutely. So this machine here has got a true 5-axis mill, the UMC 750 from Haas. We make parts like this, which is our aileron flap hanger, and it starts with a part like this.
You're basically just putting the bullet, putting it on the table, clamping it down, the CNC goes to work, got some coolant running there, and ends up with this, and then it looks like you got some automation on the back side that just pulls these things out as they're doing.
Absolutely.
So let's take a look at it. It looks like we got this arm right now. It looks like you got robot arms that are automated, putting the billet into the unit.
That is correct. We got this little robot here. All it's doing is grabbing the raw state material, loading the machine, and the machine will take off from there. Once it's done, it'll bring it back and unload it.
That kind of looks like this.
Just like that.
Okay. Why the robot arm doing this versus somebody else putting it in?
So this machine right now with these parts, it can run 24 hours without an operator there.
So I noticed that you have 3-axis, 3+ axis, 5-axis. Why the need for all the different ones? Why wouldn't everything just be 5-axis?
So a good example is this piece part here. Every side you see there would have to be flipped by a manual person doing it. So now the machines can actually do that all in one operation and without a manual operation changing out.
So there's some parts probably too that it's just not necessary to have a 5-axis if it's a
That's
very
right.
simple part. Like this one has, I see a table that's moving around as it's running. Is this called a 3+?
Yeah, this is a 3-axis machine.
Okay.
Pallet pull is the only difference on this one.
Now as we walk through, what are the other ones here? What are the differences in these?
So these are all the same exact 3-axis machines.
I hear the word term 3+. What does 3+ mean on this one?
So the 3+ means that it has a rotary on there, so you can do side work. Typically you can't do on a 3-axis machine. This is our saw department back here. Anything that needs to be cut for either the CNC mills or an actual piece part is all done right here.
So I can see the raw materials come in the door there.
Yep.
First step is they cut them the length or whatever they need, prep them to send on.
And they'll move right on that through the process that's needed next.
All right, great. I'm looking forward to seeing that. Let's go. Wow, this is a stark contrast from the buildings we just came from. I mean, there's a lot of activity going on over there, but over here it seems to be kind of slow, but obviously we've got wings hanging here. We got the fuselage hanging here. What else happens in this building?
This is Weld and subassemblies. So we build wings, we build flaps and ailerons, we build fuselages, we build floorboards. So you can see here, wing in process. Everything that you saw being made in the other shop is now coming together into a wing. So it's more tedious, it's longer processes.
Seems like there's not as much activity because
Yeah.
it just takes longer to make these big assemblies.
That's right.
Can we talk about your inventory control just a little bit? Because it seems like what happens is it's almost like FedEx. The stuff gets made all over the place,
Yep.
comes into the hub,
Yep.
and then goes back out to the
Yep.
rest of the facilities. Is that
Yep.
pretty much how it works?
You know, it gets manufactured, gets inspected, gets distributed to either a warehouse location or sometimes directly to the subassembly that's going to be made on. And then eventually all this will then be shipped over to the main building to be put on the aircraft.
Can you walk us through? Obviously, this is a fun building because it's starting to look like an aircraft.
Right.
Can you kind of walk us through why it's so tedious to build a wing like this?
Well, yeah, there's hundreds and hundreds of rivets in a given wing. There's a lot of match drilling, and everything's got to be true and straight and accurate. Every single rivet's got to be squeezed or pulled correctly. There's tolerances to how that's done, and you know, there's 2,000, 3,000 distinct operations in the manufacturing of a wing by hand, that any one of which could go wrong and cause either substantial damage or even ruin a wing. So just very tedious, very, very tedious process.
So if I accidentally drilled a problem here, doesn't take the whole wing out of commission, we just have to replace the spar?
Yep. Well, the spar would be a nightmare. Yeah. So if we damage a tail rib here, we could pull that off or replace that. But if a spar gets damaged, you may have to pull that out and replace a whole spar.
That's a lot of, so how many hours does it take to build a wing?
A wing's around 50 hours.
Okay, so that's a lot.
Yeah, it's a lot of time.
So is the XCub wing and the FX wing the same wing?
Not the same wing. Totally different wings.
What's the biggest?
Tested totally different strength and structure. You know, an XCub's 2,300 pound gross weight, so it's going to be a much more beefier structure capable of those heavier loads.
I want to switch to this next wing because I see some stuff over here that I think is really interesting to talk
Yeah.
about. A lot of the stringers and things you put through here. Now, you call these stringers?
Brace wires.
Brace wire?
Yeah.
Okay. Now, here is where the tanks go, correct?
Correct. Or
Brace
one big
wires.
tank.
One big tank?
Yep, and this is an XCub wing,
Okay, so this is XCub. So an FX would be two separate tanks?
typically.
Okay, and then you're also going to have these brace wires coming right through the tanks as
Yep.
well, right? And we'll get to see those in one of the other ones. Now, I see he's got some wires here just to make sure that it's all true and things as he's
Yep.
pulling these together.
Yeah, it's string line to make sure that everything's true and accurate where it needs to be.
So the wing obviously bends and tweaks to this line based on how he tightens and loosens these guide wires, or
Yeah, that's going to snug the whole assembly together. Otherwise, it's kind of flimsy and loose, and that just tightens everything and pulls all your center braces in and locks the whole assembly together.
walk me through from here all the way down what components we have here.
Yeah, you just have a larger brace structure here with this through tube that goes through the tank. You have your tank straps, you know, your furthest inbore rib. Of course, some of your fuel lines have already been installed. Some of your wiring here, just a ground wire is installed. And it's just piecing the whole thing together bit by bit in the right order of operations and making sure that every hole's in the right place, every rivet's pulled correctly, every bolt is torqued correctly and marked correctly.
A lot of work.
It's a lot of work.
So again, I see all the fuel lines. What are
Yep.
these main tubes here?
Those further brace, so when your drag wires are tensioned, that prevents the wing from, say, collapsing and getting any like bowed shape. Again, I'm not the engineer side of it, but it just helps further brace that whole structure because it can't expand, it can't contract. It has to stay locked into that geometry.
So it's almost like a spansion bridge,
yeah,
or
yeah,
a
you
tension
could-
kind of bridge. Like
yeah, I think that's a fair way to represent the idea.
So you guys have the builder assist program. The owner gets to come and do a lot of these steps, hands-on, an amazing experience. I have to tell you that the thing I value most about it is I understand my airplane so much more because I've been inside here. I understand the inner workings and how it's built.
Yep.
It's a huge, great education for somebody that wants to own one of these aircraft and really like to do it. It's a great experience. What are some of the pieces? We already came out of the carbon fiber, fabrication, we went through the machine shop, so they get to experience a lot of those steps along the way, correct?
Yeah, builder's gonna go through every single one of these shops and spend time in the shops. They're gonna get their hands on many different aspects of the airplane, from making piece parts to some of the sub-assemblies and forming some of the parts. All the builders I've ever known really love the experience for a lot of reasons. One, they get a deeper internal understanding of what they've built, but it's also getting to be in an aircraft factory and work on building your own aircraft, which is not a super common experience.
It's like almost like a once in a lifetime experience.
Yeah,
for sure. And I see a tension gauge here.
Yeah.
So obviously, I guess as he's truing this up, he's also pulling on these at a certain tension.
Yep. Validating that those are at the correct tightness.
I see some more. They almost look like torque tubes to me, but
Yeah.
there are more tubes, but there's more here because of.
This is your strut attach point.
Okay.
So this is all the structure of your strut attach point. Your strut's gonna lock in here and go down to the fuselage there.
All the way down by the wheel and
Yep.
the gear. The end, I know that you got the tips are carbon fiber.
Yep.
Right? And they're all made in-house.
Yep.
All of these are welded here and things as well?
That's correct. And then we bring them over here, we bend them down, weld them, trim them to shape, and get them into inventory or get them onto the rack to get built.
I see holes on these ribs.
Mm-hmm.
Does anything go through here, or is that just where the fabric?
It can depend on the system of covering, but yeah, you'll get a fabric rivet under those. It's easier to show on a completed airplane, but it's literally a pop rivet that's going to be helping keep that fabric attached to the top of your rib.
Okay, great. I know we're going to see that in a little bit. So we're getting down to, I guess, the last station of the wings, where it looks like we're doing the leading edge, the tail edge, our flap attachments, ailerons, or flaps, ailerons.
Yep.
This looks kind of like the newer G-Series flaps.
Yep.
What are the differences? I know I had the G-Series on my XCub and not G-Series on my FX before that.
Right.
But I was really impressed with the G-Series and the push rods for the XCub.
There's pilots who prefer the earlier version of flaps and ailerons, and most people go with the G-Series. I think there's maybe a little bit more surface area.
This is an actual UL wing, and in the UL, we're not using push rods like the XCub. We're using pulleys.
Yep.
And it looks like, so we're gonna have my pulley coming up the strut, my wire coming up the strut into the wing. Is this one of the attachments for the pulley?
This is a pulley bracket here. Further up in assembly, you'll get a pulley mounted in here. You'll get a teardrop cover over the top of that. When the wing's covered, your cable's gonna come off another pulley, come aft, and run out through the fabric here to actuate your aileron on the backside.
We only have one tank here on each side, right? Can I get a second, or do you need it?
Yeah, you can have extended range tanks.
And I also noticed in the UL, underneath the rear seat, there's like another header tank. So why is that there?
It's a fuel systems requirement.
So these look like flaps and ailerons.
This is getting a finished cure. It's probably waiting for an inspection, and then it'll be shipped over to the other side to wait to get painted and go on an aircraft.
Builder assist, do you do anything as an owner in this area?
Yep, they'd be involved in various aspects of the buildup of the skeleton, adding skins, putting in rivets, etc.
Okay.
Yep.
This kind of looks like a press or a brake like on the other side, yeah?
Looks a little bit like a press, but all it does is that holds the skins in a nested position in order to ensure that we keep the whole assembly tight while we rivet it up, and everything's held in its place. It's held tight, so it's a nice tight structure.
So instead of a press, it's more like a jig.
Yep.
Okay.
It's an assembly jig. Right?
This looks like a UL floor panel to me.
Yep. This is just like what we saw, prepped and ready for infusion in the other facility, in the Composites facility. So it's been through its trim stage. It's staged awaiting its brake pedals and various components to be added. And as much work that can be done on this sub-assembly will be done here, and then it'll be shipped over to be installed in an aircraft in the first station on the other side.
Language we used before, children, parent,
Right.
like there's gonna be a whole bunch of children on here that makes this the parent. I can see this whole bunch on the tables here with the rudder pedals, torque tubes, and that's all going onto this piece.
That's right.
Pretty cool. I wanna go see all the welding and the frames.
Let's check it out.
Looks like another fun area here, and
Okay.
if you're doing the Builder Assist program, this must be a really interesting place to build your frames.
Yeah, this is probably where you start to really sense that it is an airplane, because you're laying in your fuselage tubes into your fixtures to be tack welded in place. This all holds all those tubes very carefully in place. And then once those are tack welded out, those come together or come out of the fixtures and go into the mating fixture next door.
So it looks like these are probably like FX3 jigs, and then you got the XCub jigs, but where's like UL and SS and all those?
They're built here on these fixtures as well. So these will work both ways. They're compatible to those fuselage.
We got racks on wheels here of all of the tubing cut to length, ready to go.
Yep.
So then the builder assist program, or you guys just basically get those in order, get them laid into the jig?
Yep.
What's the process for making sure everything's where they need to be?
Putting together a puzzle. So every piece has to fit in just right. It's got to nest just right. You have to have minimum gaps for welding. As that's done, we try to really work that out in the initial manufacturing process of the individual pieces themselves to minimize the amount of work that the welder has to do here in assistance, say, with a builder in getting these nested in station on the fixture.
These tables are already all metal, so I guess you consider this like a weld table. So
Yeah.
you're just putting a negative on the welder on one side.
Yep.
Do you tack it in
Yep.
this and then weld it?
Yep, this will get tacked together and then this will go into the mating fuselage next door. Additional tubes that will be fixtured in to bind those two halves together. It'll all get tacked together, and then the weld process is pretty tedious. You can't just start at one end and weld the fuselage. You have to kind of bounce strategically back and forth along the fuselage, or else you'll start to tear things apart because you get so much shrinkage. This is all short from your longerons, your long pieces, but this is every connecting tube in the fuselage, kitted up, ready to go. It's quick and easy to access for either the builder or the welder who's building up the fuselage at that point.
I see some TIG welding going on. Can we go see what that's about?
Okay.
So I noticed behind us looks like the nose gear of an XCub. And TIG welding going on. And I know TIG welding typically is usually for more stronger parts or a better welding. How often do you use TIG welding versus MIG?
It makes sense in this application. The nose gear is a unique design, and it can take a beating under the right circumstances. So you want that structure to be as strong as possible.
Okay. Now in the XCub, I know we can change from nose gear configuration back to tail wheel.
Yep.
But all that assembly stays right where it is, right? The only thing that moves is the wheel.
You would take off. There's an addition to the engine mount that would come off as well.
This looks like it's fully welded.
Yep.
Final weld then, right?
Yep.
But I see a lot of green stickers and arrows. What are those for?
So this has been inspected, or at least initially inspected. They've gone over it and they've identified any little tiny pinholes, or if we happen to miss a weld or something like that, to make sure that when this goes to powder coat, every single weld's complete, there's no pinholes, that it's an absolutely beautifully perfect dialed in fuselage at every joint.
What else do you do to prepare it for powder coating?
It'll get cleaned really good, and if there needs to be areas knocked down a little bit to ensure that fabric fits correctly or that stringers fit correctly, we'll address things like that.
So what you're talking about is we want to make sure there isn't a little weld or something sticking up here, because when you put the fabric on it, it would rip it.
That's right.
So-
Or at least show through the fabric.
Okay. So any acid bath or anything like that happens all in the powder coating?
That's right.
Okay, so here clearly we got our fuel tanks. Now,
Yep.
this must be an FX3 tank because it's actually not one big tank and it's connected here.
Yep.
So you can buy an FX3 with one tank or the extended tank, right?
So this would be your extended, yeah. So this is your extended range.
This is the main.
setup. This would be a standard range tank.
Okay. When we were back on the wings,
Yeah,
we had those tension
that's right.
lines that went through that.
Yeah.
So the lines actually go through the actual tank in the middle here. So
Both tanks.
through both of them. So
Yeah.
is there a tube in the middle here?
That's right.
And it's all welded together.
That's right. That tube passes through this tank, has an opening here, another opening on this tank, and passes through the other side over here.
Goes up the other side.
Yeah, to maintain that tension and integrity of the structure of the wing.
Okay. Never know that. And if I wasn't doing a builder assist, or I didn't come here to really see what my plane is built like, I would have never thought about that.
It's kind of
And
mind-boggling.
That's important because you might have some buyers that don't understand this part of it. They might take the tank lid off the top of their plane and think they can just pull these tanks out or something.
Not
And
so easy.
that is not going to happen.
Right.
So, Robert, this is so far one of my favorite buildings because things are starting to look like an airplane.
Right.
All these fuselages, wings, elevators, ailerons, it's stuff that starts to get me excited as a
Yep.
pilot. So from here, we go to where?
We're going to go to final assembly. So all these pieces will start being pulled together, and gradually you'll see the airplane emerge.
Okay, so those facilities are on the other side of the airport, right?
That's right.
All right, let's head over there.
All right.
Join us in the next episode where the aircraft starts to come together, covering the wings, watching the paint process, and finally the aircraft gets its engine.